Good evening, guys. Today, let's discuss about buck-boost converter. Uh, it is a type of DC to DC converter, and whose output can be greater than or lower than the input voltage. That is the input supply voltage, and uh, it is different from other converters like flyback and pushback converters where there is electrical isolation, and in buck boost converter there is no electrical isolation. We have only a MOSFET, a switch, or a transistor in a broad sense, and it will do the work. Okay, so we have the circuit here. First, let's discuss about each operation or its working. So we have the circuit of the buck boost converter here. We have a MOSFET here, a switch. I'm trying to explain this using PSIM. That's why I'm using this circuit diagram. So we have the supply voltage here, a DC supply voltage, and a MOSFET is here with a getting block. And we have an inductor, diode, a capacitor, a resistive load. Okay. So let's before we discuss about the operation, first we should know that this buck boost converter, it is a DC to DC converter where the polarity of the output voltage will be in opposite with the supply voltage. Okay, so let's discuss the working of it. So at the first instance, from this supply voltage, from this supply, the current will flow from here in this direction. And suppose if this MOSFET, if the switch is turned on, if the switch is in the on position, the current will flow here and it will go through the inductor, which will charge the inductor like this, plus minus. And since current chooses the shortest way without much resistance, it will go through here and back to the source, because the current won't flow this way because the diode is will be reverse bias. So there is no current flow through the diode. So the current at the first instance, the current will flow from the supply to the inductor, then back to the source. At this instant, there won't be any output voltage. Okay, this will be the first instance. In the next instance, let's say the switch is turned off. Okay, let's say the switch is turned off. In this, we will have another working here. From here, the polarity of the inductor will change from plus minus to minus plus. Okay, because so that the diode will be forward bias. So the current will flow from here. There will be no supply. There is no supply. The switch is off. So the current will start flowing. The energy stored in the inductor, which was previously stored in the inductor, will be discharged from here. It goes to here and then here. Also, it goes here through the load and here like this. So the diode will be forward bias and there will be flow in the load. At this instant, we will find current in the load side. Okay, there will be voltage in the load side, which we can see using PSIM. So this, let's talk about the third mode. Okay. During this time, the switch will be turned on again. During this time, when the switch is on, the normal procedure of charging like the previous one, it will take place, but there will be current flow in the load because from the inductor, the charges were already discharged earlier in the second instant, and in third instant, some charges were stored in the capacitor. those charges, it will be released in the third instant. So we will still get the output voltage in the third instant. Like this, the cycle will continue from the third instant. Charging, first instant, charging to the inductor, then discharge from the inductor in the second instant, which will charge the capacitor, and current will flow through the load. And on the third instant, discharge from the capacitor, which will still supply current to the load. Like this, the process will continue on. So let's open PSIM and let's verify it's working through simulation. Okay, so I have the circuit here, the same thing. We have the supply voltage here, and this is V in, the input voltage, and this is the output voltage, and I have given some values like this one 100 millihenry. The capacitor value I have given 1000 microfarad, and load value I have given 10 ohms. So these are some random values so that I can get the desired output. But the main thing is this one, this getting block. It says that in the buck boost converter, buck means step down and boost means step up. So this circuit can be either used as a buck, or this circuit can be either used as a boost converter. That means it can either step up or step down, depending on the duty cycle. If I give the duty cycle less than 0.5 means 0.5 into 360, that is 180. If I give this switching points less than 180, if I give the switching point 180, then the input and the output voltage will almost be the same. Let's see. This is the input voltage. I've given 100 volt here, and the output voltage, it will be almost 100. Okay, it will be almost 100 because it will be almost 100 in the opposite polarity, because I've given the duty cycle 0.5. So if I give the duty cycle less than 0.5, say, let's say I give say 80, which is less than 180, then it will become a buck converter, that is step down. So let's see again. V in, V out. See, the input is 100 volt and the output is around say 30, that in the opposite polarity. This becomes the buck converter. Okay. Now let's see about a boost converter. Suppose I give about say 280, which is more than 180, and this will, let's see the waveform. This will give an output which is more than 100. That means it becomes a boost converter. Okay, that's the working. And one more thing is we can consider the waveforms also. I've included an emitter here to find out the current waveform of this one inductor, the waveform of the inductor current. So for this, let's see this one. Let's see inductor current and the output voltage. Let's choose all of them. Here, let's decrease this one. Let's decrease the timeline to around say 0.2, so that we can study the waveforms easily. And the frequency also, let's reduce to around say 200, and let's see. Okay, to study the waveform of the inductor current, let's change the value of the inductor of the getting block to frequency to 50 Hz, and then okay, like this, and the timeline to about 0.5, and let's study the waveform. Okay. Okay, so like I explained earlier, see, during this part is for the first instant, that is during the charging of inductor. Like I told you, during the charging of inductor, there won't be this green is the output voltage, this blue is the input current, which won't change. It will be a straight line since it is a DC input, and this current is the inductor current. See, this is the inductor current I, okay, and this one during the first instant from here to here, the value of the current will be increased since the inductor is in the charging mode, and during this time there won't be any voltage. See, it is 0, and in the next instant, from here it reduces slightly. During this time, this is the period when discharge from the inductor takes place. At the same time, the voltage across the load will be available, will be there. It is here, and from here to here, in the third instant, there will be charging of inductor. And there won't be any discharge from the inductor, but there will be discharge from the capacitor, like I told you earlier. That is why the value of the voltage will be reduced, but not 0, will be reduced, but still there will be voltage across the load. This is the part where the discharging of the capacitor took place, and from here again the next cycle repeats. Okay, inductor discharge, the value of the output voltage increases. From here to capacitor it decreases again, and then inductor discharge like this. Okay, this is the graph. Okay, that's all. So this is the working of the buck boost converter, and the thing we should remember is the buck boost converter can be either in the buck mode or in the boost mode depending on the duty cycle. That means if the duty cycle is more than 0.5, it will be a boost converter, and if it is less than 0.5, then it will be a buck converter. Okay, thank you.